Good afternoon. Today my topic is vector calculus and application. It's coming in a BSc mathematics second year paper. So I am going to cover the topic is vector differentiation. What is vector differentiation? Define physical application of derivative of vector. First, let the scalar variable of t represent the line. This is line. R vector being the point. P is a moving point. This is a notation. This is called velocity. That is dr. When you differentiate dr by dt, we get a velocity. When you differentiate velocity, we get acceleration. This is always, it is equal to d square r by dt square. This is called acceleration. And magnitude, otherwise is called a length of the r vector. Square root of x square plus y square plus z square. So this is a position vector, xi vector plus yj vector plus z square. So this is the basic. First velocity, the acceleration, and r vector, xi plus yj plus z square is displacement. This is important notation. Let us recall some results in vector. I dot I. When you take dot product I dot I, j dot j, k dot k, the value is 1. Suppose take cross product I vector cross j, I vector, similarly j, k, the result is 0. And then I cross k is minus j, k cross j minus I, j cross I equal to minus k. Here I cross j, you go right first order is I vector j, k. Proper order I cross j, k, j cross k, I k cross I equal to j. Suppose the order is not proper, become negative. So this is we call the definition. Now what is vector differential operator? Here we call as a del. This is a notation of delta. Vector differential operator delta is defined as delta equal to I dou by. This is called dou by dou x. Dou by dou x we know very well. I just recall differentiate partially with respect to x. Similarly with respect to y. Similarly with respect to z. Here I, j, k are called a unit vector along the three rectangle axes OX. I vector represent by OX axis, j vector OY, and k vector is z axis, that is OZ axis. So here vector differential operator, remember delta equal to I dou by dou x plus j dou by dou y plus k dou by dou z. Next note, delta is an operator and also is called a vector quantity. This is summation. Right, it's a summation. So shortly we can write summation of I vector dou by dou x. So I vector dou by dou x plus j dou by dou y plus k dou by dou z. So this, instead of that we can shortly write I vector dou by dou x. And del pi, just you substitute del pi is a vector. Three components are dou by dou x, dou by dou y, dou by dou z. Here pi is a constant, then del pi equal to 0. So you consider pi is a constant. Pi is a constant, pi equal to c. When you differentiate partially with respect to x and similarly y is a answer is 0 only. So what? Del pi equal to 0. You just substitute the pi here, pi. So when you differentiate pi is a constant, dou pi by dou x first equal to 0. Similarly y, similarly z. So anyway del pi equal to 0. Let's prove that gradient of a constant is 0. So what is gradient? Gradient is nothing, that is phi. Del phi. Here we have to prove gradient of constant. What is constant? We take symbol is c. Let pi of x comma y comma is 3 variable. Here constant is c. Simply we can write pi of c. So when you differentiate partially with respect to x, when you differentiate constant you get is 0. So anyway whatever x, y, z becomes 0. We know the formula, distance or the formula del pi equal to I dou pi dou x plus I dou pi dou x. This is called gradient. Shortly we can write GRAD. When you substitute, you get the answer. So I prove the gradient of constant is 0. Next result. Now the given function phi of x, y, z, find del pi. Okay. Given dou pi equal to x, y, z. Differentiate partially with respect to x. And just recall the definition. Differentiation. So dou pi by dou x. You know partial, if you learn in partial equation, first b is max. Anyway, recall. When you differentiate partially with respect to x, so y is kept constant. Okay, y is constant. When you differentiate x is 1, so that is right y of x. Now differentiate partially with respect to it. Now x is constant. So differentiation of y is 1. Now next differentiate partially with respect to z. Here x, y is a constant. Differentiation of z is 1. So I get it x. Now write the formula del pi. Del pi equal to I vector dou pi dou x. Similarly j and k. You just substitute a corresponding value. Dou pi dou x value is y z. Dou pi dou y x is z. And dou pi dou y z. Just rearrange the value. This is the answer for del pi. This is a method to find. Suppose the problem is given pi, to find the del pi. Next, here also given pi, find del pi. But they give one more point at the point asking. The previous problem just find the del pi. In this problem they given find del pi. Also they given at the point they asked to find the del pi. So given pi equal to the function. Same formula. I vector dou pi dou x plus j and k similarly. Now again differentiate. Differentiate should be very careful. Differentiate partially with respect to x. So when you differentiate x square, you get it 2x. Y is kept a constant. Now differentiate partially with respect to y. So here x square is constant. Differentiation of y is 1. Here minus 2. Here also z is constant. Difference of y square is 2y. So 2 2's are 4. And finally z. Dou pi by dou z. In first term we don't have z. So x square y theta is a constant, but differentiation constant is 0. Minus 2 is a constant, y square is a constant, differentiation of x z cube. When you differentiate z cube, you get it 3z square. So already 2 is there, so directly write 6y square z. Now write the formula, that is del pi equal to, I told many times, just substitute the corresponding value. In the place of dou pi dou x is 2xy, similarly dou pi dou y, similarly dou pi dou z, and just simplify, get the answer. This is the next. One more step. At the point again, the point is given is 1 comma minus 1 comma 2. So the point is given. This is taken x, this is y, and finally z. Just substitute, in the place of x is 1, in the place of y is minus 1, in the place of z is 2. We substitute, or we can simplify, you get the final answer, minus 2 vector plus 23 j vector minus 25 k vector. This is one of the important questions. They given r vector, they also give the condition r vector into modulus of r vector. This is our identities you can remember. Del r into 1 by r vector, del 1 by r into minus r vector r cube. This is one of the important results. Del r power n equal to n r power n minus 2 equal to r vector. And finally, del f of r, del r, del f r. You can remember all the results. But I proved only few. Yes, proof. R vector is given. So this is also given. R vector equal to modulus of R vector. For modulus, you just substitute R vector value here. You know the value of modulus vector. Modulus is square root of I coefficient square, that is x square, and j, that is y square, and k, that is z square. Now squaring on both sides, all become r square. On the right hand side, square root and square will cancel. Now we have to differentiate partially with respect to x first. So when you differentiate r square, so we get 2r dou r by dou x. When differentiate x square, that is 2x. Y is it as a constant, so when you differentiate y is it becomes 0. Now 2 will get cancelled, so the answer is dou r by dou x equal to x square. Similarly here, differentiate partially with respect to y. Again left hand side you come to r. So with respect to y, dou r by dou y. X square, z square is a constant, is alone, it becomes 0. Differentiation of y square equal to 2y. So 2 will get cancelled, dou r by dou y equal to y. Similarly, dou r by dou z equal to z by r. So very important result. Remember this result. So dou r by dou x is x by r. Dou r by dou y equal to y by r, and dou r by dou z equal to z by r. This is very important result. Next, another part. Yes. Delta r power n equal to n r power n minus 2 into r vector. This one I will prove. What is delta? Just now we saw the result. Delta is nothing, I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Just r to the power of n. Now multiply. So what happened? I vector dou by dou x r power n plus j vector dou by dou y r power n plus k vector dou by dou z r. I multiply each and every time. Now I have to differentiate r power of n. R power of n differentiate partially with respect to x. Similarly y and z. So when you differentiate r power of n, you know the differentiation basic formula n r power n minus 1. After the differentiation r with respect to x, now you can write it dou r by dou x. This is the idea of chain rule. So I substitute n r power n minus 1 dou r by dou x. Similarly y, same n r power n minus 1 dou r by dou y. And similarly z, n r power n minus 1 dou r by dou z. Now in all the term this is common, that is n r power n minus, take it out. What is the remaining term? I vector dou r by dou x plus j vector dou r by dou y plus k vector dou r by dou z. So previous step. This way already found, that is dou r by dou x equal to x by r. Similarly y by r, similarly z by r. I just substitute that dou r by dou x value, dou r by dou y value, dou r by dou z value. And then take denominator and all the time having r is common. Take it out, r is common, write the remaining term. This is well known result. Xi plus y equal to r vector, I got it as RHS. This is important result. Hence it is proved. Next, you have to remember all the results. Pi and psi are scalar point function. C is any constant. You have to prove all the result. That is del c equal to 0. Another one is del into c pi equal to, correct. Take c is out. C into del pi. And third one is del of pi plus psi equal to del pi plus del psi. And fourth one is del of pi psi equal to pi of del psi plus psi of del. This is like a UV method. And this is like U by V method. We already learned in a product rule and a quotient rule in a differentiation. Like this, just like a similar idea. First I prove that delta c pi equal to c delta. C delta pi. When you do the differentiation, we can keep c as a constant. Similarly, right? This out c, then you can write del pi. I take LHS delta bracket c pi. So delta you know very well. I dou by dou x, similarly j and k. Now write c pi. And just multiply each and every term. I vector dou by dou x into c pi. Similarly j dou by dou c pi into k dou by dou c. This is simply consolidate and write it summation. Summation means including j vector, k vector. Short we can write it summation of I vector dou by dou x. When you differentiation c is a constant, then you can write dou pi by dou x. Similarly come y, similarly come z. Therefore c summation of I dou by dou x, you can write it del pi. Here I missed j and k. Instead of that I just write it summation of I vector dou by dou. Hence it is proved the RHS result. And now direction derivative. The direction derivative is a very important problem. One of the important problem, 5 mark question. This is the main result. Del pi into A vector by modulus A. The direction derivative of a scalar point function of y is given direction. A is the rate of change of y. The direction of A vector is a component of del pi. The direction of vector is given. This is very important. The formula del pi into sometimes they given n vector. Instead of A vector with modulus of A vector, you can write it n vector. N vector equal to A vector by modulus A vector. Next, maximum direction. They ask to find what is the maximum direction derivative, that is del pi. Magnitude, just find the modulus of this value. So here three formula. One is to find the direction derivative, that is del pi dot A vector modulus. Another one is find the maximum direction derivative. Another one is find the that is length of the maximum direction derivative, that is del pi. Three formula. We just see the one problem. And another is unit normal vector. So n vector unit normal vector format del pi by modulus del pi. And angle between the two vector is n1 vector or n2 vector to cos theta, but n vector del pi by modulus. So I just specify. We see only the direction derivative problem. Find the direction derivative of pi. The given pi at a point in the direction of 2i minus j minus 2k. First consider the given function is pi. Pi equal to x square z minus plus 4xz. The given direction is what? This is you take as a vector. 2i minus j minus 2k. Now find the modulus of a vector. How to find the modulus of a vector? Just take the square root, I vector coefficient square, that is 4. And similarly, j vector coefficient is minus 1. K vector coefficient is minus 2. You can simplify and get it 3. And next, del pi. Find the del pi. Just del pi formula and the pi already fixed. Just now I thought how to find the del pi value. Similarly, you can do sub del pi. You can differentiate partially with respect to x. Just explain only one term. With respect to x square differentiation is 2x. Y is a constant. Here x differentiation is 1. So 4 is a square. Similarly y, similarly z. Now the given point, now that point we will substitute x, y, z. If we substitute, we get it 8i vector minus j vector minus k vector. So you got it del pi. Now write the formula del pi dot a vector by modulus a vector. Just now for the previous slide we saw the del pi vector. Just substitute. And a vector is 2i minus j minus 2k by modulus vector is 3. Now then the dot product. I already told you I vector dot I vector equal to 1. So this we get 8 2s are 16. Similarly, minus 1 into minus 1 plus 1, and then minus 10 to minus 2 is 20. You can simplify and get it. Your answer is that is divided by 3. This is a way to find the direction derivative problem. Thank you.